Hello and thanks for watching today's video where we're going to go through some basic triangle proofs. So in previous videos we talked about the common theorems, the definitions for triangle proofs. You should know these combinations by now. We have the 5 combinations for proving triangles are congruent: side, 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 angle, side, angle, 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 side, and hypotenuse, leg. Then we also went through in the last video the common rules along with explanations of each one, kind of how they can help you with the proofs that we're about to actually do now. So now it's time to finally put all these rules, all these confusing definitions together in hopefully a way that makes sense and helps you reach the goal of proving the triangles are congruent. So again, the tips, I talked about these a little bit last video. Always a good idea to draw and mark your diagram before doing anything. Always look for any shared parts of the two triangles. These parts will be automatically congruent by the reflexive property. Remember the definitions. So if you're watching the video and you forget, I recommend you go back to the beginning, look it up, write it down, and hopefully you'll be able to do the proof. And then, so now I just want to talk about two-column proofs. I feel like most of you probably know what they are, but some of you don't. It's just a way mathematically that proofs work. So a lot of times we'll start with a statement. I have it drawn here. Actually, I don't need to draw it again. We have a statement. So this may say angle A is congruent to angle C. We have to give a reason for that, and the reasons are generally these. So that might be because of the reflexive property. It might be because the definition of an angle bisector, something like that. And then the first statement's always going to be your given. So before you can start a proof, you have to be given some information about the triangles, or else it would be impossible. So you're going to be given a lot of information, and you're going to write all of those as your first statement, and the reason will be given. And then you kind of work through it, and the last statement will always be what you're asked to show and prove. So if your goal is to prove triangle ABC is congruent to triangle BDC, or whatever it is, your last statement has to be triangle ABC is congruent to the other triangle, and that's the only way you can do it, or else you did the proof wrong, because that has to be, that's what you're reaching, that's what you're trying to get to, so that has to be what you prove. And always draw a picture with and mark it with your information. I actually wrote this here too, but that's how important it is. You've got to draw a picture, or else I really don't even know how you'd be able to do it. So let's look at some very basic ones. I'm not saying these are tough, but the intention for these is to get you used to writing two-column proofs and kind of understand what they are, where they come from, and kind of how to tackle them. So let me write my proof up here. So statement, and then reason. Hopefully I have enough space. All right. So I'm trying to prove that triangle ABC is congruent to RST. Okay. And I'm given that BC is congruent to ST. So as I go, I'm just going to mark my two shapes. And so BC congruent to ST. Give my little dashes there. Angle A is congruent to angle R. So I'm going to put angle A here. Angle R, and I'm going to put one dash. The dash implies that they're congruent. That's how you know that this one is congruent to that one. Okay, and then now angle C is congruent to angle T. So angle C, I'm going to add 2 dashes. And then angle T, I'm going to add 2 dashes as well. Okay, so now what I'm given, I write down every statement again. So even though it's here, I have to write it again. BC congruent to ST, and angle A congruent to angle R. Then I have angle C congruent to angle T. So that's my first statement, and my reason for all of them is given. That's an easy step, not hard at all. And now the goal is to prove that ABC is congruent to RST. So if the goal is to prove two triangles are congruent, I know that my final reason has to be one of my combinations, because those are the ways you prove triangles are congruent. So let's think, do we have information right now to use one of our combinations? And we actually do. We have angle, angle, side. We have AAS. So our reason is going to be AAS. And that gives us the fact that triangle ABC, so this is our final reason, triangle ABC is congruent to triangle RST. This example was really easy. We didn't even have to use any of our new stuff, but I just wanted to show you what the two-column proof looks like, and this is it. And the reason was AAS, so angle, angle, side is what you would say. So hopefully that makes sense. Hopefully now you understand, okay, this is a two-column proof. I can do the next one. And now the next one's not going to be as easy. You're going to have to actually use one of the things we've talked about here, one of our rules. And this is more of a typical two-column proof. You're going to be given something, you're going to have to go through some steps, and eventually you're going to be able to prove that they're congruent. So again, when we start our proof, let's write our statement, draw our t-chart, and sometimes these will be provided for you, but I think it's best to get in the habit of them not being provided for you, because when they are provided, you'll know how many steps there are, but when they're not, it's up to you to try to figure out how to do it. So statement and reason. So again, let's start with what we're given. AC congruent to EC, and then BC, and you can write all of these in one step just because there's only one reason for it. So that's why you can write like two statements with one reason. All right, so now we need to mark our diagram. So AC is congruent to EC, okay? BC, 2 dashes now because it's a different line, is congruent to DC. Okay, so now the goal is to prove congruence. And I know of some ways to prove congruence. Those are all those combinations that we've talked about in the past. That's like SAS, ASA, SSS. And now our question is, well, which one can we use here? So instantly I see, well, I'm given that 2 sides are congruent to each other. BC is congruent to DC and AC is congruent to EC. So now I know, well, my combination is probably going to have the 2 sides. So that leaves me to SSS and SAS. So now the question obviously becomes, well, which one do I use and how do I know? So SSS, let's just go through and see if I'm going to prove by side, 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 and then I have to prove that AB is congruent to ED. So if I can prove that AB is congruent to ED, then that's a proof that works and it would be fine. So the thing is with proofs is sometimes you can have multiple ways to get to the right answer. But when I see that, I feel like that would be a pretty complex proof. I'm sure you could prove it, but I think SAS may be easier. So remember the rule for side angle side. That means you have to have 2 sides that are congruent, and also the included angle has to be congruent. And what do I mean by included angle? That's the angle in between the sides. So in this case, with side BC, the angle has to be this one because then it connects to side CA. And with DC, it has to be that angle connecting with CE. So we're trying to prove that those angles are congruent. Do I have an easy way to do that? And I actually do. Those are vertical angles, and vertical angles are congruent by definition. So let's do a quick throwback of what vertical angles are. Those are the angles that are on opposite sides when we draw an X. So that's like this and this. That's exactly what we have here. And we also would have the same situation considering these 2 angles. And those are congruent, and these are congruent. Definition of vertical angles. So that's one of those rules that we talked about in a previous video. You really got to commit those to memories, or else these proofs are just impossible, really. You have to know that to be able to take the next step. So now I can write that angle. I'm going to say BCA is congruent to angle DCE. And my reason for knowing that, well, that's because of the definition of vertical angles. So I'm going to say definition of vertical angles. And these are vertical angles, and the vertical definition says that they are congruent. So that is my reasoning, and that I can say that those 2 angles are congruent. And then now I have enough evidence to do to prove what the goal of the question was to prove, which is triangle ABC is congruent to triangle DEC. I have the side, I have the included angle and the side, so that proves that they are congruent. So that's one of my combinations. So triangle ABC is congruent to triangle DEC. Remember that the last statement, is always going to be what we're trying to prove, because that's where we have to end, because that's where we've been working for the whole time. So that has to be the final statement. And the reason in this case is side angle side. So you just write SAS and you're good to go, because that's the combination that allowed you to say that this triangle ABC is congruent to triangle DEC in this case. So hopefully that was a good introduction to proofs, how you solved a 2-column proof, and I really hope that you realize how important it is to know those definitions, because you never know which one's going to pop up and which one's going to be handy. In this case, it was vertical angles are congruent, but next time it might be something to do with angle bisectors. So hopefully this was a good introduction, and we'll get into a lot tougher proofs later on, but let me know if you have any questions. Thanks for watching.